Hello, in this video we're going to talk about the equation of a line. I'm going to tell you where it comes from, I'm going to tell you what it looks like, and I'm going to use these three examples towards the end of the video to show you how to get it in these three specific cases. So first of all, what is the equation of a line? And to answer that, I'd like to point out that instead of a line, this is what a line looks like. Instead of thinking of a line, I would like you guys to think of millions and millions of dots. So we have a dot here, a dot here, a dot here. There's dots in between. In fact, there's no two dots you can draw without being able to draw something in between, unless the two dots are the same. So there's billions, infinite dots on this line. There's so many, it looks like a line. So that's what the definition of a line is. Or another way we often talk about lines is, we talk about it as being a point, often the point where it hits the y-axis, and then a direction. And a direction, we use m for the direction. So that the m we use is the slope. We say if m moves 1, if x moves 1, how much does y move for this line? So that's what we define as the slope. We say rise over run. This is the rise, this is the run. So in this little example, maybe x moves 1, and then how much does y move? Again, this is just a drawing, but that looks to me about, I'd say 4/5 it moves, or minus 4/5, it goes down 4/5. So in this example, m would be equal to minus 4 over 5. And the starting point maybe would be 0, 1. Although when we get more used to it, we can use any point really to start with. I think it's just often useful to talk about that one. Now, what does an equation of a line look like? Really, it has a few defining characteristics. An equation has to have an equals, really, to be an equation of a line. Other than that, it only just has to have, I guess, an x and a y somewhere. And it usually has numbers, but this is actually an equation of a line. This is enough. In fact, you don't even need both x and y now. I think about x equals 2 is a line. It's a simple one. It looks just like that, just straight down. You have y is equal minus 2. That's a line, it's just straight across. Let me put in an x and a y axis. Oh, this is the y axis here. Before I get a little lost, which I already did. Y is equal minus 2 would be here. These are equations of lines. I guess one of the most defining characteristic is that the x and the y, sometimes one of them is 0, and they have no powers. They're just power of 1. Everything's to the power of 1. If there's a 2 there, a squared, you no longer have a line. You have a quadratic. If there's a 3, you now have a cubic, and so on. So that's what it looks like. Much more commonly what it looks like would be something like this. 2x plus maybe 4y equals 7. We'd often write it like that. Again, the equals is the most defining characteristic. Another most popular way to write equations would be y is equal 3x minus 7. Something like this. We often put the y in its own. I'll talk about this one now in a moment or two. That's why this is my favorite. It's very powerful. Okay, I'll rub this out. I'll show you the two most common ways to find equations of a line. One of them I'll do with part 1. Another I'll do with part 2. And then I'll talk about part 3 a different way. Okay, one of the most common ways, I'll do part 1 here as a way, an example, to find the equation of a line is we start off knowing that a line looks like this. Y is equal mx plus b. Now every line will look like this, even if x is 0 or something all the time. Even if b is 0, maybe, well, m maybe is a 0. But every line can be made look like this. That's why we call this like a generic equation of a line. This is one of the two forms of an equation of a line. It's what you start with. You're given this in formulas. And it's a very powerful one because m is the slope and it's sitting right there. B actually means something. B is the point where it hits the y-axis. In this case, this drawing, maybe it's like 0, 3. So maybe B is 3. So it's a very useful form of an equation. So if you're given this, let me show you how you would use this to answer part 1. So in part 1 they tell us m, which is great because we have m here. So we'd write this again, equation is equal to x plus b. And remember, this is already the equation This is already a equation of a line, so all we really want to do is find what m and b is. So we get to this, and we have 1 point, and there's going to be enough information, because you've got to remember what this point tells us. It tells us that when x is 3, y is 2. It tells us when y is 2, x is 3. So when y is 2, x must be 3. That's what this tells us. If this is on the line, that's what defines the equation of a line. So this is just, this is easy enough to solve. We have 2 is equal 6 plus b. You don't even have to rearrange it more. I think we can just look at this and say, what adds on to 6 to make 2? Well, it must be minus 4. Minus 4 adds on to 6 to get 2. So b must equal minus 4. And the equation of a line, this is the generic version. The equation of this line will look like this. Y is equal to 2x minus 4. That's what an equation of a line looks like. That's what this equation, in fact, of a line looks like. Looks like the sun just went in and changed the colour of everything. Okay, let me rub this out and we'll do part 2. And we'll use a different type of an equation to get part 2. So there's another generic equation we often see for equations of a line, and that's y minus y1 is equal mx minus x1. Now both this equation and the previous one could answer either of these questions. They're both perfectly fine ways to do it. They're slightly different. Some countries actually use one more than another. I like to think we can all use both of them though, because sometimes one is more useful than another. Okay, so what we need to finish this question, because we want to leave y alone, we want to leave x alone, we basically just want to get rid of these things. x1, want it to go, y1, I want it gone, I want a number there, and m, I want a number instead of that, I want it gone. Now what x1 and y1 is, it just means any point that's on this line. And this question actually told us 2 points that are on the line. So you can pick any one of these points. That's up to you. But something we need is m. So we're going to have to go back to the last video and remember that we have an equation that tells us what m is. M is equal y2 minus y1 divided by x2 minus x1. That's a way we can find a slope given 2 points. And here's 2 points. So let's just number these. Let's just say this is the first guy, x1, y1. This is the second guy, x2, y2. And we'll just fill this in. And that becomes minus 7. y2 is minus 7. Minus 3. So there's a minus here, and there's a 3 here. On the bottom line, we get x2 is 4. A minus is here. And x1 is 1. Let's clean all this up. We get minus 10 divided by 3. That's what m is. Now at this point, you could just answer the same way we answered part 1, using the other formula. But no, we can still use this formula. And by the way, this is how you would use the other formula on part 2 as well. So let's still use this formula. We write this guy out now. This will give us the answer. Y minus y1 is 3 equals m is minus 10 over 3. You better get used to this, by the way. Lots of numbers come out looking like this in equations of line. Lots of slopes, I should say, come out looking like this. Lots of fractions. Okay, minus 1. And that's an answer. This is an equation of a line. It's a bit messy, it's a bit dirty, but it is an equation of a line now. But let's clean it up a little bit. I like to multiply things out. Maybe multiply the 3 across, different things. Lots of people, they don't like to leave fractions, so they multiply everything by 3. But let's do some of that. Let's multiply this in first. Y minus 3 is equal minus 10 over 3 multiplied by x. And then minus by a minus is a plus. 10 by 1 is 10 divided by 3. Actually no, I wouldn't like to leave these two numbers here. Let's combine them together. Let's first rub this out. Just give me a bit of room. So if I add 3 to both sides, I get y is equal minus 10 over 3x plus 10 over 3, and then add 3 plus 3. So let's clean this up. Y is equal minus 10 over 3x. Let's see, what is 3? 3 is the same as 9 divided by 3. So 9 plus 10 is 19 over 3. So that is a final answer there. Let me just point out one other way we might write that, because I didn't do it in part 1. I meant to do it in this part. Some people don't like fractions, so they end up multiplying everything by 3. So let's see what that would look like. 3y is equal minus 10x plus 19. That's the same equation. That equation will look just the same as this if we draw it. Again, lots of people don't like this either. They don't like x having a minus. And they don't like two things being on different sides. So they might add 10x to both sides. 10x plus 3y is equal 19. Lots of people like writing their equations like this. Personally, I think this one's much better because it tells us so much information. It tells us the slope is right here and the y-intercept, which I haven't talked about yet. I'll wait until the last part to talk about. But this is perfectly good as well. I think even these are probably good enough most of the time, although they're a bit messy. Alright, let me rub this out and we'll do part 3. It's very short, I promise. Okay, in part 3, they've actually drawn a picture, or I've drawn a picture for you, but I've drawn a picture and I'm asking you to get the equation from it. I've left numbers out, apologies for that. Let me put in some numbers here. 1, 2. It's a fairly simple question. Don't worry too much. Now, the great thing about this question is, and the great thing about equations that look like this, or the general formula that looks like this is why I like this one so much. We can use this to answer this question very, very quickly. Because m is just the slope. Now, to get the slope, we still need 2 points. But luckily, they've given us that in the question. They have 0, 1, and 1, 2 is on the line. But let's not do the maths. Let's have a look at it and say, how much does y change when x changes 1? So when x goes 1, how much did y change? It went up how much, basically, is what we're saying. Up is positive, down would be negative. So when x goes 1 this way, y went 1 that way. That's what the slope is. M equals 1, or maybe I'll write that. Yeah, it's fine with this. M equals 1. I can tell that from seeing 2 points on this line. So this is nearly answered. Y is equal, well, 1x is just x. So now I just need the number b. Now, like we did in part 1, I could do that. I could do what I did in part 1. But no, there's a real interesting thing about the letter b. And that is when x is 0, let's stay with this guy here. When x is 0, y must equal b. So when x is 0, that's anywhere on this line, y must equal b. And when x is 0 here, y equals 1, plus 1. And we call this guy the y-intercept. Because this number here, plus 1, always tells us where a line will hit that. It's really useful, that, because often x being 0 is where we start the world. Maybe distance equals 0, time equals 0. It's a very important thing. It's a starting point, if you will, this 1 in this case. And that's the answer, by the way, in this question. We have an equals, we have an x and a y, and no other letters. Alright, so that's a few ways we can find the equation of a line. If you have any questions, let me know. In the next video, I'm going to talk about what would happen if they give you an equation of a line. How would you get some points out of it? How would you get, more importantly, the slope out of the equation? It's not too difficult. It's going to be a shorter video than this one, and I'll hopefully see you then.